So we've learned two different ways to solve quadratics, by factoring and by the quadratic formula. What we haven't talked about in depth is when you would use each one, and that will come. We will get to that point. But I want us to be able to understand the difference and be able to show that we understand. So solve by factoring. I have my A, my B, my C. I have 5, 4, and -1. There's nothing that divides into all three of those, so there is no GCF on that. So I go to my box. I know my 5r squared is the top left. My -1 is the bottom right. Draw my X. My A times C is at the top. B is at the bottom. 5 times -1 is -5. B is +4. So I need two numbers that multiply together to make -5 and add up to +4, which means I have one negative factor and one positive factor. And since the 4 is positive, the larger factor is positive. So -1 and +5. -1 times 5 gives me -5. -1 plus 5 is 4. So I have a -1r and a 5r. And again, what I'm looking for were, what were these numbers that started out here to get those answers? Well, 5r squared and 5r both have a 5r in common, which means this side would only have an r left. To get -1r in the top right, I'd have to take that r times -1. To get 5r in the bottom left, I'd have to take 5r times +1. So 5r minus 1 times r plus 1 equals 0. 5r minus 1 equals 0. R plus 1 equals 0. 5r equals 1, so r equals 1/5. R equals -1. So my solution set here is 1/5 and -1. Those are the 2 points where that function crosses the x-axis. And I should know that, and I should be able to explain that by now. Now the next one says solve the equation with the quadratic formula. Again, you need to know the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. We have to make sure that one side is equal to 0. It is already set up that way, so I don't have to move anything around. So I have my A, my B, and my C. Being very careful, A is +5, B is -4, C is -28. You have to be cautious of your negatives. So when I substitute in x equals a -4 plus or minus the square root -4 squared minus 4 times 5 times -28, all divided by 2 times 5. The double negative at the front here goes positive, so I have x equals 4 plus or minus the square root. -4 squared is +16. -4 times 5 is -20. -20 times -28 is a +560. And that's all going to be divided by 10. So x equals 4 plus or minus the square root of 16 plus the 560, which is 576, divided by 10. By square root that 576, it's 24. So 4 plus or minus 24 divided by 10. And this is where we have to separate them out, the plus 24 and the minus 24, to get our solutions. So x equals 4 plus 24 divided by 10, 28 divided by 10. They're both divisible by 2. X equals 14 fifths. And then you have x equals 4 minus 24 divided by 10. So negative 20 divided by 10. X equals negative 2. So your solution set would be 14 fifths and negative 2. Now, the good news is the main part of this lesson, we're still using the quadratic formula, it doesn't change. Where this one gets harder is we're now going to get into irrational answers. Everything we did on Monday was rational answers, so we ended up with a perfect square under that radical sign. That is not going to happen today. So we're going to have some simplifying radicals that is going to happen, which makes this section tougher. We're not learning a new formula, but now we've got to put some other skills into practice, and that's where this one gets tougher. Now, because these answers don't come out nice and as pretty, and I know 14 fifths here isn't necessarily pretty, but you can do the math. Because there's going to be radicals left in our answers, we're going to be simplifying the radical and giving the decimal equivalent. So I have a couple problems here just to practice calculator work on getting that decimal equivalent. So problems 3 and 4 here, it's as if we've done the whole quadratic formula, we've simplified the radical, we're down to this. And if you're using one of the calculators from mine, you can put this all in at one time. You could really put, but when you go to do this, this is the key here. Order of operations, we needed to do all the math on the top or in the numerator before we do the denominator. So when you input this into the calculator, you have to start with parentheses. I know it doesn't show in the problem there, but you have to put the parentheses in to show what you're doing. So you want to start your parenthesis, -5 plus 3 radical 5. And then you have to move your cursor out and in your parentheses. You have to make sure in your calculator that all of that is in parentheses before you do divided by 2. Now, if you have, that's if you have a multi-line readout calculator. If you have a single line readout calculator where you can't see the entire equation you're putting in, you actually have to do this in parts. And you would have to start with the radical. You would have to do 3 times radical 5 equals plus -5, then divide that answer by 2. But if you have one of these multi-line readout calculators, you type that in and then you put, again, all of that is in parentheses and we divide it by 2. Now, most of the calculators in this classroom are set up in math mode. In math mode, I put all that in, and what did I get? Yeah, I got back exactly what I put in. So and that's a great thing to help you, but to get the decimal equivalent to understand, there's a key on the calculator. It'll either say S and then have a double arrow in D, or some will say F and a double arrow in D. If you hit that key, it'll take you from standard to decimal. So there's a key. If you don't know where that key is or you're not sure, let me help you find that key on how you can get from math mode to the decimal answer for this. Okay, the number you're looking for, the correct value on this one, to round it to the nearest hundredth, would be 0.85. If you aren't getting that, let me know. Let me help you understand the calculator, because this is part of this, is understanding how the calculator works. And different calculators work in different ways. They all get the same answer when programmed correctly, but you have to know how to work the calculator. I'm going to put the second one up just so you can compare. So if I do -5, start my parentheses, -5 minus 3√5, finish my parentheses, divide by 2. The other answer that you should get is -5.85. I'm going to pause here for a moment. If you've got those answers, go ahead and work on 4. I'm going to pause for a moment for those that may be having trouble getting that answer. All right, so again, as we're learning, different calculators work in different ways, but the key is we should be, whatever's in the numerator needs to be in parentheses for that order of operations to be handled correctly. So here I have -5 plus the square root of 65. And then I want to divide that by 2. As a decimal rounded to the nearest hundredth, you should have gotten 1.53. Then if I do -5 minus the square root of 65 divided by 2, I should get -6.53. So that's just a little calculator practice. On the type of answers you're going to be getting on these irrationals, and knowing how to convert that to a decimal, knowing how to work your calculator correctly to convert that to a decimal. Now, those answers we were just looking at, it doesn't automatically come out looking like that to start with. Those may have been simplified based on the math. So this is why we practiced simplifying radicals before, because you do need to be able to leave it in simplest radical form. So the first thing here is we have to look at that square root. So I need to try and simplify the square root of 98. So we have to simplify this square root of 98. We have to find out, are there any perfect squares? So again, we talked about knowing what the factors, I start out with 1 times 98. I know 98 is not a perfect square. 2 times 49. Well, there's my perfect square right there. So 98 is really the square root of 2 times the square root of 49, which becomes the square root of 2 times 7. So we can replace that square root of 98. This would be equal to 6 plus 7 radical 2 divided by 2. Now, sometimes you can go even further if the denominator can divide into both numbers, both whole numbers. You can do more simplifying. But this is why we have to understand how to simplify radicals, how to get those perfect squares out of the number and simplify it down. And you need to know this skill without relying on the calculator, because I think I'm going to give you some questions that I'm not going to allow you to use calculators for, a couple of them just for practice, because you need to know the math and not just what the calculator can do for you. You need to understand why that is the answer. So the square root of 160. Again, we need to see, are there any perfect squares in that 160? Well, 1 times 160. Two times 80. Three doesn't go into it when I check, just to make sure. I knew it, but when I check in the calculator, I get a fraction. 160 divided by 4 is 4 times 40. $160 divided by 5 is 32. I know 6 doesn't go into it because 3 didn't go into it.
Wouldn't 4 go into it? Because that's a square root of squared.
Wouldn't what?
Wouldn't 4 work? Or 4 times 40? Because 4 is...
So the question being asked is, well, we found a perfect square in 4. So if I rewrite the 160 as the square root of 4 times the square root of 40, yes, 4 is a perfect square of 2, but 40 still has a perfect square in it. Then you would have to do the square root of 40. And this is what happens if we stop just at the first perfect square we find. That is not the most simplified answer yet, because 40, if I look at the factors of 40, obviously 1 times 40, 2 times 20, 4 times 10, 5 times 8. So there is another 4 here. So I can break down 40 as the square root of 4 times the square root of 10, which breaks down as 2 times the square root of 10. So now 40 becomes 2 radical 10 And you have 2 times 2 radical 10, which becomes 4 radical 10. So just because you find a perfect square doesn't mean it is the largest perfect square. If we had continued on with all our factors of 160, we would have found that 16 was a factor, and it is the largest perfect square, which gets us the 4 radical 10. So now I have 8 plus 4 radical 10 divided by 4. Because 8, 4, and 4 are all divisible by 4, I can simplify this. 8 divided by 4 is 2, 4 divided by 4 is 1, 4 divided by 4 is 1. But it has to be able to go into all the terms. You can't just simplify one and not the other. And this one would rewrite as 2 plus radical 10. We wouldn't write the ones. So sometimes you can simplify them and not have a fraction, and other times you simplify them and you do have a fraction. But this is why we have to know how to do the math and make sure that we're not leaving any perfect squares still under our radical. So number 7, negative 3 minus the square root of 48. Again, we need to simplify that square root of 48. Seeing what perfect squares are there. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So again, this one has 2 perfect squares. It has 4. But if you go for 4, you're going to have to then simplify 12, because 12 can be simplified. If you find that largest one in 16, so the square root of 3 times the square root of 16 leaves me the square root of 3 times 4. So I have negative 3 minus 4 radical 3 divided by 2. You cannot reduce the 4 because you can't reduce the negative 3 out front. And you also notice we aren't combining the negative 3 minus 4. I'm not doing that math and saying negative 7 radical 3. Having a radical is a lot like having a variable. You can only add radicals together. So I would have to have another number with a radical 3 to be able to combine it. Otherwise, it has to stay alone. And that answer would be negative 3 minus 4 radical 3 divided by 2. And then number 8, negative 6 plus the square root of 120 divided by 2. Again, the square root of 120 we need to simplify. Obviously 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 7 doesn't go in. 8 times 15. 9 doesn't go in. 10 times 12. So when we look here, we have the 4 times 30. There's our 4. And if you think about 30, what are the numbers that multiply together to make 30? 5 and 6, 3 and 10. There's no perfect squares in any of those numbers. So in this case, square root of 120 is the square root of 4 times the square root of 30, which becomes 2 times the square root of 30. And that is simplified. Even though the number under the radical is 30, there's no perfect squares in 30. So that's negative 6 plus 2 radical 30 divided by 2. This is a case where we can simplify because 2 goes into both of those. So this can be simplified as negative 3 plus radical 30. We wouldn't write that 1 out in front. Just like other math, that 1 is something we would not write.